ships to avoid places like the Guayhanas Humpback Whale Reserve. And that shows up as a hotspot. And do it in a way that's systematic. So companies could say, well, I'm willing to deviate from a straight line path by so much in order to conserve whales, and they can make that a policy. And that's what this trade-off could kind of do, is incentivize a win-win scenario so that you push people to this corner where they're minimizing the impact to wildlife and still maximizing their industry return. So diving a little bit more into the wind energy valuation, so we can, this is using this Stanford Best model just to come up with a revenue and a cost. So there's transmission cable, and there's fixed infrastructure, and there's wind. And those are what goes into the variable of how profitable a given 10 square kilometer pixel is. And then if we're looking at impacts, so this is long-term and operational, so you might want to site in space with the birds. And then this is episodic with the acoustic impacts. Otherwise, it's probably not too big a deal. So we want to site in time with the cetaceans activities. So we can look at, take all these bird species, look at their distributions, rank them based on their sensitivity to offshore wind. So there's placement based on their flight heights, their maneuverability, and their extinction risk, and comes up with a number. And then we can collapse those into a single layer where we see that there's like a very strong northerly component with less risk down below if you're interested in overall impacts of birds. And then we could do something very similar with the cetaceans, but in this case we take our previously modeled density surface models that were done month by month, and we create a map like that for each month. And then, and then we get that trade-off. So I'll just show you what that trade-off thing looks like. So we get into an actual app. So yeah, you can go to the, and I'm sending in the revision to that manuscript tonight for PLOS 1. Okay, so this is, so we see the trade-off on the right, and this is mapping bird sensitivity on the x-axis. So we're trying to, our overall utility is going to be over here, where we have the least sensitivity to birds, and we have the maximum utility to offshore wind. So we could do things like, we could zoom into that quadrant, and then we could do things like lasso these guys. And then it'll highlight on the map, because I can take that user interaction and then say, okay, now highlight on the map where those points are. And then I can go to that map and I could, okay, so I know, let's say I'm already in North Carolina, okay, this looks good. All right, so now I'm going to look at that little pixel, and now we can see that, okay, November, that's when we're least likely to impact whales. And this is mostly driven by the right whale. There's less than 500 individuals of the North Atlantic right whale, and it migrates from the Gulf of Maine, why they call it the urban whale, and down to off of Florida, where there's some breeding areas. So that's where that's your best time of year to do things like pile driving, which could otherwise impact these guys. All right. So, yeah, and then the routing is very similar. That uses what's called a least cost model, which is a graph theoretic model, to try to route around, come up with the shortest route, and it adds, so you add more weight, and you come up with the different routes based on adding differential weights between linear or just geographic distance versus cranking up the weights on that surface, which becomes a resistance surface. Anyway, you get different routes depending on where you're okay on that trade-off. And then I'm, in the interest of time, going to just stick with the static models of these. But you get the idea that you can choose different scenarios. There's output scores, there's input layers, there's different goals. And each of these then can actually produce even more criteria below for you to select. And as you hover over countries, that flower plot updates. That's a D3 thing too, add-on. And I already went over that framework. This is looking at it. The gray area is masking out this criteria, which is looking at overall competing uses with renewable energy. And then you can optimize, say, like, okay, I only want to look at 8 meters per second or more areas, and it'll expand the mask. And then you can click on a given pixel, and it'll tell you what those competing uses are for that pixel. And then this is the eDNA one, where you can look at taxa by rank, and then by the value of the taxa. So phyla, genera, family, and then the value of interest. And you can add multiple values, and you can look at it by site or date. So these are just filtering criteria that then allow you to look in space and in time at what the data is doing. And then the connectivity, you can draw a box, and then it'll tell you for Monterey Bay and Florida Keys what the input larvae are, where they're coming from, based on the current conditions for the models simulated for that time period, or they can tell you where they're going to. So the import and the export of larvae. And that was based on using this toolbox from Eric Tremmel and Jason Roberts. And then the reporting one, so this kind of blends the R markdown thing that I showed before with the shiny thing. And the idea here, so this was with Frank really wanting to see something where we could, how can we allow people to interactively report on where they stand with the Sustainable Development Goal 14. And this then shows you the different species richness by country. And then we developed with Dan Otis too, the sea surface temperature and the chlorophyll, and then you can get time series and maps, and then you save these plots, and then you can save that report as a bookmark. You could send to a colleague that gets all those layers that you highlighted, or it can generate a PDF or a Word doc. So that was kind of an experiment. And the idea, the bigger idea, is to be able to extract data to a given region, calculate essential biodiversity variables, and report back from global to global portals, as well as integrating other local data. So we can do little packages and functions that do bits of that. And part of that also, making it really portable and easy to spin up, is using this other thing called Docker, which takes a whole software stack and allows you to spin it. So I did that with the NREL. You can run one line and it'll download, and then if you have Docker installed on your Mac, on your PC, on your Linux server, on an Amazon server, what have you, you could be a minute away from having a fully launched application. All right, I already told about that. So I think I'm going to skip the, this is the shiny stuff in the interest of time. But it's pretty doable. I encourage you guys to try it out. And this is really great. This is what I end up doing. I Google and the error message, and then I copy and paste from Stack Overflow. So I think some of you know what I'm talking about. That's how things actually happen. So Tuesday, somebody's going to talk about Shiny with your Tampa Bay R user group. That's so cool. And there's a great bunch of materials with the Eco Data Science group that some of us from the Ocean Health Index started, and now there's a bunch of people contributing. It's so cool. And there's there's a training section on my website where you can get, like, I taught in environmental informatics how to do this stuff, and there's a whole website online, of course, GitHub, and fully open. There's a workshop that got canceled because the government shut down. I was supposed to do Thursday, Friday with the National Park Service on how to do this. So I'm going to update that, and yeah, software carpentry, data carpentry out there. So yeah, And Harry Potter World in Florida here. I was out here a couple years ago. That was super fun. And I got to play with wizards. And it can feel like magic when things work. So I encourage you guys to check it out. Yeah. I think that's it. Thanks.